Okay, this is Thursday, February 1st. This is the sort of second part of 5-4. We just had a little introduction to 5-4 yesterday. We were anticipating that Professor Ouija was coming today, but he sent an email saying that he couldn't make it. And so now we're going to use these sum and difference formulas as we go through things. So I'm just going to kind of remind us that first of all, our formulas themselves that we have to be able to use are sum and difference formulas. The sign of the sum is sine cosine plus cosine sine. The difference, sine cosine minus cosine sine. And then, just to kind of get the pattern in our heads, when we're doing cosine, if it's of two angles added, we subtract. If it's subtracted, we add. And we do cosine cosine minus sine sine, or cosine cosine plus sine sine. And if it's the tangent of u plus v, we have the tangent of u plus the tangent of v all over 1 minus tangent u tangent v. And then, well, I'll move that. Then if they're subtracted, on the top they're subtracted, on the bottom they are added. Using kind of that same pattern or format. Then we talked about this because truly you're going to get the sine, cosine, or tangent of some angle. It is not going to be one of these from the table, but it is going to be something that generally you can get a sum or a difference from something. And I just use the table like as reference angles, but keep in mind these can be in other quadrants as well. And I could have to take 120 minus 45. I don't know. I just and get some angle there as well. So here's our first problem: is number 1, find the exact value, and that's the hint to us that we are asked to find the exact value. So that means even though pi over 12 isn't on the table, since it's saying exact value, we should be able to write it in this instance as a sum or difference. And when we get to the test, we'll have done some other things as well. So we'll have to be versed in other dynamics as well. So this is the sine of pi over 12. And I'm not saying that there's just one thing, but what is something that we can use to subtract and or add? But pi over 12 is pretty little to get pi over 12 that's on the table. Pi over 3 minus pi over 4. And so, now I'll say this, and let's see, maybe I can just copy. I think I don't know what I want there. I'll copy all that. And so I'll group these together first. So they're in a nice little group, and then I'll copy that. And so, that's the deal, is you have to be able to paste. You have to be able to decide what that is. So you might want to have these in twelfths, and especially that's in twelfths, so that'll make it a little bit easier for you. And so we can take pi over 3 minus pi over 4. We can take pi over 4 minus pi over 6. Either way, we should get the same equivalent answer as we go. So my thinking through of that, I used 4 pi over 12 minus 3 pi over 12, which is pi over 3 minus pi over 4. So that's what our sine is going to be equal to, equals the sine of pi over 3 minus pi over 4. And just a little caution, and so I'm going to get rid of that. A little caution, because somehow people, I don't know, start doing funny things here. So the formula that we're going to use is the sine of, did it say u and v? Yep. The sine of u minus v is equal to, is equal to sine u cosine v minus cosine u sine V. And so there's our formula or format. And so it's actually going to be the cosine of pi over 3 times the cosine of pi over 4, and somehow people miss cosine and sine sometimes, and people start going like pi over 3 times pi over 4, but that's not what it is. So just be careful of that. So this is going to be the sine of pi over 3 times the cosine of pi over 4 minus the cosine of pi over 3 times the sine of pi over 4. And then these are, at this moment, all things in the first quadrant. And so they're right on our table of values. Do you need me to make the table, or do you know the table well enough? Yes or no? It doesn't hurt to make it? Okay. So I'll just make it one time, and then if I need it more, sine, cosine. Oops. Okay, so there's our table, and then it's just a matter of putting things in. Sine of pi over 3, square root of 3 over 2. And in this case, they're all in the first quadrant. If they were in different quadrants, we would just have to, be aware of what the positive or negative sign would be. This is square root of 2 over 2 minus cosine of pi over 3 is 1/2 times sine square root of 2 over 2. And so we get square root of 6 over 4 minus square root of 2 over 4. And so then our final result, and maybe I'll just move this. Oh, no, I won't. Just kidding. My bad. I can't move that out of my way very easily. And so that is, when I give that answer, then it has to stay as the square root of 6 minus the square root of 2 all over 4. So my result here, and since I ran out a little out of room, I'm just going to rewrite it. The sine of pi over 12 is the square root of 6 minus the square root of 2 over 4. So the good part of that is that is an exact answer. Whereas, if we couldn't do this as something that is related to the problems that are on that table, we would have to get a decimal approximation. And the problem with that is if we end up needing to do something with that, we can kind of lose the closeness to that answer as we go through. And so we will have some in radians, some in degrees, things like that as we go along. So here is, I guess the next one is right there. Find the exact value of the cosine of 75. You're going to find once you've done a few of these, they're very similar to each other. And there's often more than one way to do this as well. So this one is the cosine of 75 degrees. What could 75 be equal to? 30 plus 45. And not that I'm going to use it, but what is 120 minus 45? Is that also 75? So, you can sometimes use more than one thing. In the end, it'll work out to be the same thing as you go through. So for this one, we're going to use the fact that cosine, so we'll just use that one. It's the easiest one. The cosine of u plus v. So I have to slide that over a little, is cosine u cosine v minus sine u sine v. And so when cosine, when it's added, we use subtraction and we do cosine cosine and then minus sine sine. So this is going to be, first I'll just write it this way, cosine of 30 plus 45. And again, if I do 45 plus 30, it all works out in the end to be equivalent answers as I go. And so that is going to be cosine of 30, cosine 45. Minus sine 30 sine 45. And then we just pop those in from the table. Cosine of 30 is what? Square root of 3 over 2. Cosine 45 is square root of 2 over 2. Sine of 30 is 1/2. Sine of 45, square root of 2 over 2. And if you have had trouble with these before, you know, now's a good time to really solidify that. It'll just make your life a little easier. The 45s are always the square root of 2 over 2, so that's easy to remember. And if you're finding the cosine and the sine of something, you know, one is going to be the square for like 30 and 60. One is going to be the square root of 3 over 2. The other one's going to be 1/2. So it's just being careful. So this one's square root of 6 over 4 minus square root of 2 over 4. So square root of 6 minus the square root of 2 over 4 is the cosine of 75 degrees. Oops. The exact value of the cosine of 75 degrees. And so what do you notice? It's the same answer, right? And we know that that can happen in any of our work as we're going through these. Now, we could not know this angle, but we could know something about the ratios that we're using. And we can either use identities or we can draw little pictures of triangles, whatever we want to do, because, you know, I don't think they tell us we have to use the identities. Let me look. So here's our next question. We might not ever know what the angle is, but we might be told to find the exact value of sine of u plus v. And you could substitute any of those things we just had, those 6 equations. When we know the sine of u is 4/5 and u is between 0 and pi over 2, and we know the cosine of v is negative 12/13, and where v is between pi over 2 and pi. So they're in different quadrants. So we can use identities, we can use little triangles. My thought is to do a little triangle for one and an identity for the other. Do you know what I mean? Then we've done them both. Does that sound okay? And then you can pick what you want to use for this one. So for you, I know that all students take calculus, and this is in the first quadrant. So that's nice because that means the sine and cosine are both positive. And by the way, I didn't really state this, but since sine of u plus v is sine u cosine v plus cosine u sine v, I know I have to know the sine and cosine of u and the sine and cosine of v. And this one I'll do as an identity just because the denominators are going to be easier. And maybe you're recognizing this anyway. And do be cautious because sometimes, well, I'll say that after I do it. And so we know sine squared u plus cosine squared u equals 1. This is 4/5 squared plus cosine squared u equals 1. So cosine u equals plus or minus the square root of 1 minus 4/5 squared. Do you agree with that? I kind of skipped a few steps there, but just to make sure I know what's happening. And then since we know it's in that first quadrant, we can say, okay, it's going to be the positive square root. And 4/5 squared is 16 25ths. So I'm going to change 1 into 25 25ths minus 16 25ths. And so I get the square root of 9 25ths. And so I get 3/5. And what I was going to say in the beginning is do be careful when you see these 4s, 5s, and 3s, because they don't always use 3, 4, 5 triangles. Do you know what I mean? And so you don't want to accidentally pick something and say, oh, if this is 4/5, that has to be 3/5, without thinking at least a little bit through the problem. So for this one, that means the sine of u is 4/5 and the cosine of u is 3/5. And they were both positive because of that quadrant and everything. So that's strategy 1, using the identities. Strategy 2 is you can just make a little triangle. This one, all students take calculus. I'm between pi over 2 and pi, so that means I'm right here. So my cosine is negative, but my sine will be positive. And so I'm just going to pre-write my answer, or my space for my answer, I guess. Cosine u is negative 12/13, and I'm just going to write a little positive sign there. Usually if it's a positive, I don't have a problem, but if I had determined it was negative and I didn't write it right away, sometimes then I just never remember that it was negative. So that's just my own strategy not to make a mistake. We'll see how it goes. And so then I can just make a little right triangle if I want, and I'll say V is right there, and cosine is the what side over the what side? Adjacent over hypotenuse. So the adjacent side is 12, the hypotenuse is 13. I don't care about the plus or minus part because I've already figured that out. And then I can get that missing side, which is the square root of 13 squared minus 12 squared. So really I do the Pythagorean identity either way, but I just, I don't do it like like that, I guess. So what is that? 169, minus 144, and that is 2, 5, and so that's 5. So this side is 5. So the sine is opposite over adjacent, so it's positive 5/12. So that's all preliminary work to figure out what the sines and cosines are. And without knowing the angles, doesn't really matter to me at this point what the angles are. And I just know I have to find the sine of u plus v. And I'm just going to pause a moment. Or did I make a mistake? Oh, yes. Oh, thank you. Yeah, I was. Oh my gosh. Yeah, that is the tangent. So I made a mistake. Let me just kind of state that out loud on the slide here. I had given the tangent of u, and the sine of u is opposite over hypotenuse, so 5/13. Thank you so much for reminding me of that. And I was going to check my numbers in the next step, but I'll check them here now just to make sure. Okay, and right at this moment, I'm just going to pause and say, do you all agree that if you needed to find the tangent of u or the tangent of v, you could, correct? Yes? Yeah. And so you could be asked for the sine, cosine, or tangent of u plus v or u minus v in this situation, and you could find any of them. Do you agree with that as well? So it's just a matter of, plugging it into the correct formula as we go. So in this case, we're given the sine of u plus v. And so that is sine u cosine v plus cosine u sine v. Sorry, my C didn't turn out very well. And so then that should be 4/5 times the cosine. Oh, here's another mistake I did. These should be V's. Wow. I'm just all about mistakes today. And then cosine V is times negative 12/13. and then plus, and cosine u, which is 3/5, and sine v, which is 5/13. And so this is where I was going to check myself, and I am good to go. Notice that the denominators are the same, and as long as, you know, when we write these, we anticipate these denominators to be the same and those to be the same. So when we're multiplying, we should still get denominators that are the same. So what is that? Negative 48 over, what's 5 times 13? 65. And plus 15 over 65. And then what's negative 48 plus 15? Negative 33 over 65. And that is the exact value of sine of u plus v. And so we never had to know what the angle was, and we can still get the exact value there for that one. Oh my goodness. Yeah. Wow. I am just, my day was going better before right now. Wow. Uh, yes. What was it? Now I forgot. Negative 33 over 65. Huh. Wow. Okay, boy, I'm kind of batting not very well today. So the next one uses arc value, arc trigonometric, so inverse trig functions as well. So here's our next one. Now, not only might we never know the angle, we might have to, you know, never really know actual values, and we might have to give an answer as an algebraic expression. So this is number 4, and it's to write the cosine of the arctangent of 1 plus the arccosine of x as an algebraic expression. And so I'll just write the problem. I don't know why, I just like to do that. Arctangent 1 plus the cosine of, parentheses, the arctangent of 1 plus the arc cosine of x. So I'm going to right away just kind of think about generalizing this. So this is the cosine of u plus v. So u is kind of this arctangent of 1, v is this arccosine of x. So I'll have to handle those. But my formula then is I want the cosine of u, cosine v minus sine u, sine v. So now I'm going to plug that into the original and write it over here. And I feel like it is going to take me a little bit extra space, so maybe I want to have that way. So I need the cosine of the arctangent of 1 times the cosine of the arccosine of x minus the sine of the arctangent of 1 times the sine of the arccosine of x. And I just fit it in. Yay. So again, for these arctangent, arccosine, I can use either Pythagorean identities or I can make triangles. What do you want to do? Make triangles? Is that all right? Okay, so I'll do this arctangent 1. I'll just, arctangent. Arctangent 1. I'll do it in this kind of red color so that I can kind of think about that. So If I know the arc tangent is 1, that means, what do I know? Tangent is what side over what? So 1 over 1. So what can I do? My picture is obviously not correct then. Opposite over adjacent is 1 and 1. So what's the hypotenuse? Square root of 2, right? Square root of 1 squared plus 1 squared. So square root of 2. And I need, so this is my situation that I just got. I need the cosine of that situation, and I need the sine of that situation. And so we'll call that I'll just call it the sine of u and the cosine of u. So the sine is going to be what? Square root of 2 over 2. So it's going to be opposite over hypotenuse, 1 over square root of 2. So square root of 2 over 2. So we don't necessarily know the angle, and we weren't given any, quadrants or anything. So we're going to be very generalized, but we will use positives, and we'll have the expectation that it would be, some kind of spin of that. And cosine will be the same thing. So we know a reference angle really right now, but we don't necessarily know exactly the angle. And so I'm just going to put that in here. So that's the cosine, which is this really bottom one, square root of 2 over 2. And this sine is also square root of 2 over 2. So that's what I've kind of figured out from that piece. Now, the other picture that I have is I know the arc cosine of x. And so if I draw a little triangle here, which didn't turn out great, so that's like saying that's x over 1, and cosine is the what over the what? Cosine is adjacent over hypotenuse, so x here and 1 there. And then since that's the hypotenuse, this is the square root of 1 minus x squared, correct? 1 minus x squared. And like I'll call that angle V just to make it easy. And so then you know, the angle is the arc cosine of x, so the cosine is, so let's see, what do I need? I need the sine and the cosine. The sine of v and the cosine of v. So the sine is adjacent over hypotenuse, so square root of 1 minus x squared over 1. Cosine is just that x that we knew it was. And I am going to write it over 1 just because the other ones are fractions, and I can kind of put them in here. So the cosine of the arc cosine of x is x. And by the way, do you remember that? That's from, I guess, the last chapter, that the cosine of the arc cosine of x would be x. And I don't want to forget my minus there. And then the sine of the arc cosine is going to be that square root of 1 minus x squared over 1. And so then when I clean all this up, my common denominator is what? 2. So can I write it right away as 2 or not? Yeah. And then I have the square root of 2x. Sometimes I write that as x the square root of 2 because then I don't drift my radical over that, but I wouldn't necessarily have to. Minus the square root of 2 times, and I'm just going to leave it like this, 1 minus x squared, like that for a minute, because what do you notice about that numerator? There's a common factor. What is it? Square root of 2. And so I would just factor that out. It's the square root of 2 times x minus the square root of 1 minus x squared all over plane 2. And am I okay with a rationalized denominator? Ooh, My denominator is rationalized, and so I can just leave that one. It's still a little on the ugly side, I think, but I can still look at it that way. And then our next problem is to kind of just maybe validate an identity using one of these sum or difference formulas as we go. So here's our next problem, number 5, and then I have some for you to try, and so maybe we'll do that today. So use the difference, excuse me, formula to prove the co-function identity. And so this is, we want to prove that the cosine of pi over 2 minus x equals the sine of x. And so if we're proving an identity, just a reminder, we can't cross that equal sign as we go through. So I'll be working on the left or the right, do you think? The left, yep. I'm going to work on the left. And I have a formula for this, correct? And I'm just kind of noticing we haven't done any tangent problems yet, but that's okay too. And so when I put this in the formula, do I need to write the formula on here, or do you remember the formula now? Okay, uh, or okay, so cosine of u plus v, that formula, or u minus v. I'm sorry, it's u minus v. So do I need to write that, or do we know it? So it's going to be cosine pi over 2 cosine x. What's the symbol here? Plus sine pi over 2 sine x. And, you know, from your table or whatever, what's the cosine of pi over 2? 0. Cosine x plus, what's the sine of pi over 2? 1 times sine x. And then this is just 0, and so it's 1 sine x. And so it's just sine x equals sine x. And that's all you have to do for proving it. But I will just say this. You do have to write, you know, like the formula out if you're proving this, and then substitute in the ones you know. Because think about the fact that you could do that for a lot of different things as we go through this. Oh yes, I do. Before the try these, I do have a couple more, I guess. And so we'll do the try these probably tomorrow, and we'll do 6A and B because 6B has a tangent problem on it anyway. So now that last one was to simplify so it wasn't kind of like this, but they told us what the answer was. And so now in this one, we have to figure out what the answer is. And so 6A is the cosine of parentheses theta minus 3 pi over 2. And gosh, it's a lot of cosine ones, it seems like. So I know. So cosine theta sine 3 pi over 2. What do I, oh, I'm sorry. I did that wrong, didn't I? It's cosine what? Cosine theta cosine 3 pi over 2. What goes here? Plus, and then sine theta sine 3 pi over 2. So I'm at 3 pi over 2. You know, we haven't done that one for a while, I feel like. 3 pi over 2, it's right on the quadrant. It's right there. If I wanted to label that point, it's 0, -1. And this is cosine, comma, sine. And so the cosine of 3 pi over 2 is 0. The sine of 3 pi over 2 is -1. And then these can just say, or stay, wow, yeah, be nice to me. Cosine theta times 0 plus sine theta times -1. And so this one cancels out, and so it's negative sine theta for that one. And again, you know, we want to kind of show things out as we go through it. Then the next one, 6b, I'm just going to write it here. Tangent of theta plus 3 pi. So 3 pi is an interesting value. You know, it's still going to be pretty easy to determine, but it's not one we use super a lot. Anybody remember the formula to want to tell me for this one, or do you want me to write the formula down? It's a fraction. Yeah. So if it's plus on the top and minus on the bottom. If it's minus on the top and plus on the bottom. That's the big difference. So tangent u plus v is tangent u plus tangent v over 1 minus tangent u tangent v. So just remembering to multiply those, and then kind of, you know, you're going to get a common denominator. You might have to invert and multiply, you know, if you've got a lot of fraction work to do here. So in this one, we have tangent theta plus tangent 3 pi over 1 minus tangent theta tangent 3 pi. So I don't know, the way I think about this is at 3 pi, if I start here, pi, 2 pi, 3 pi, I can end up right there, and that point is -1, 0. This is cosine, that is sine, and so tangent is sine over cosine, so 0 over -1 is what? 0. So the tangent of 3 pi is 0. As we go. So then I'll just kind of put that in, tangent theta plus 0 over 1 minus tangent theta times 0. I guess I'll do it like that. And then what is that going to turn out to be? Tangent theta plus 0 is just tangent theta over, and then 1 times 0 is 1, so tangent theta. So in this case, the tangent of theta plus 3 pi is the same as the tangent of theta. And, well, that should make sense to us. Do we agree? That should make sense. So I'm going to stop there, and then next time when you get here, we have a homework check, and I'll just give you the homework check and 1, 2, 3, 4 problems for you to try, and then we'll kind of move on from there or see what we have to do. Because we have another problem or two, I think, 1 or 2 problems to do after this. So that is our lesson for today.